Okay, today we're going to talk about step 4 in division of radicals called rationalizing the denominator. So on your table of contents, go ahead and write that in. I'm going to be on page 21 of my notebook. You may be on a different page. If so, write down your number. I'll give you a few seconds here to write that down. Okay, it's going to be slides 92 through 94 in your digital notebook. That's what you're going to want to update. Those are where your guided practice problems are. So let's start page 21. What does it mean when we talk about rationalizing the denominator? So in math, just like we're not allowed to have negative exponents in our answer, we're not going to be allowed to have radicals in a denominator in our final answer. So we rationalize the denominator in order to be in proper form. A final answer may not contain a radical in the denominator. So the way we're going to eliminate that, so to eliminate the radical from a denominator, both the numerator and denominator will be multiplied by a radical equal to the radical in the denominator. So you want to go through and do your other steps first, right? You're going to want to simplify. You're going to want to do any elimination division that you can do. And then if you're left with a denominator that contains a radical, you're going to rationalize it. After rationalizing it, you may have to then simplify, again, the inside and outside numbers, especially in the numerator. And why we are able to do this? Well, this is just like finding an equivalent fraction. If I had the fraction 1/2, if I multiplied both the top and the bottom by 2, I'd get 2/4, and 2/4 is equal to 1/2. So that law of equality, or finding the equivalent fraction, is what allows me to do that. What does that look like algebraically? Well, if I have 1 over radical A, and I multiply both the top and the bottom by radical A, I'm going to wind up with radical A over just plain A. Because remember, any radical times itself just equals itself, the value of the radicand, especially if you're dealing with a square root, right? Because two or a set of matching factors creates one number outside of the radical. So step 4, specifically step 4, rationalize the denominator multiply numerator and denominator with a radical equal to the radical in the denominator. And that's going to lead to our answer. So remember, this is step 4 because it's just a breakdown of that step that we didn't do earlier. So let's look at some examples. Say we have 5 over radical 3. Well, radical 3 cannot be simplified. 5 cannot be simplified with anything down below because there's only a 1 out in front of this radical. So according to my rule, I'm going to multiply both the top and the bottom by radical 3. By doing that, I'm going to wind up with basically radical 3 times radical 3 is going to give me a 3, and 5 times radical 3 would be 5 radical 3. I check, there's nothing to eliminate, so that's my final answer. What if I have something like 8 over radical 20? Well, radical 20 can be simplified, right? Because the prime factorization of 20 is 2 times 2 times 5. So I'm going to wind up with 8 over 2 radical 5. This is going to simplify to be 4 over radical 5 because 8 and 2 have a common factor, or 8 divided by 2 is 4. So I'm going to multiply both the top and the bottom by radical 5. And my final answer is going to be 4 radical 5 over radical 5. Right? So these are the basics. Put that up a little bit higher, give you a couple minutes to write it down, hopefully. So again, to rationalize the denominator, we multiply both the numerator and the denominator with a radical equal to the radical in the denominator. Now, it's easier if we simplify first and we do that, but if you don't wind up simplifying, you're going to get the same result as long as you simplify at the end. Here, we had to simplify 20 to make it a 2 outside and a 5 left inside. 8 divided by 2 will leave us with 4, and the radical 5 on the bottom, leaving me to multiply both the top and the bottom by radical 5. So my final answer is 4 radical 5 over 5. Because again, remember, any radical times itself equals itself, or the value of the radicand, right? So it doesn't matter what it is, any radical times itself is the value of the radicand underneath. And that is how you rationalize the denominator.